Hey everyone, in this video I want to talk a little bit about how to read METARs and TAFs. We're going to talk a little bit about what they are, and we're going to show you some examples on how to essentially read and use them. So we're going to start off first with just talking about what a METAR is and therefore how to read one. So a METAR is essentially just a weather observation at an airport. And most airports, regardless if they're big or small around the United States, have a METAR that is associated with that airport or airfield. Now, if you have never seen a METAR before, it can look a little bit complicated. The same thing with the TAF because it's all written in code. But once you essentially understand what you're looking at and you understand what these different things mean, it almost becomes second nature on how to read one. So kind of just to look at a very basic METAR, this one is a really good example just because it has some weather elements put into it. Now, some METARs are longer than others, again, depending on what the weather is. So in this case, just to kind of break everything down, the first line here, this would be what type of product this is. And again, this is a METAR. The second line here, this is the station identifier. So if it was, let's say, Denver International Airport, this would be KDEN or KDEN for short. If this was Los Angeles, this would be KLAX. Boston would be KBOS, so on and so forth. The third line, this would be the date and the time of the report. So in this instance, it's the 16th of whatever month this is. And the time is 1753 Zulu. So this was basically the METAR for 18 Zulu. Now, typically METARs, especially if they're automated, but even in the olden days when you had a human observer that would be basically writing this by hand, these reports basically came out once every hour, unless there was something of importance going on or some kind of impactful weather that was going on. Then at the very beginning, before it says METAR, you would see a line that would indicate that this is a special report. So it would say SPECI or SPEI for short. The fourth line basically just denotes that this is an automatic weather observation system that this is basically generated from. Every airport in the United States, most of them at least, will have some kind of what we call an ASOS system. ASOS is an automated weather observation system. It's basically a joint partnership between the FAA and the National Weather Service that we can basically help each other out by getting different observations at different airports. Now, they will almost likely, especially in this day and age, be automatic unless it is human induced, and it necessarily won't say automatic. But 9 times out of 10, even if an airport does have an observer at it, they will basically just edit what is already produced by the automatic weather observation system. So the fifth line, this would be wind. In this example, it's the wind direction followed by the wind speed. So the wind direction is 140 degrees. So that means the wind is coming from 140 degrees. So that's a little bit more of a southeasterly wind. And the wind is blowing at 21 knots and it's gusting, hence the G, to 26 knots. If there's no wind gust, then you wouldn't see G26. But in this case, there's wind gusts, so it denotes gust to 26 knots, which would be right around 30 miles per hour. The next line here, this would be the visibility. Here you can see that there is restricted visibility. There's 3/4 statute miles, meaning to say that visibility is generally less than 1 mile. And there has to be a reason for that, and it has to, because visibility just doesn't, lower on its own. At the very least, it should be some kind of heavy fog, or in this case, what is the weather that's causing this low visibility. So the weather parameter, what's actually happening at this location, will always follow the visibility. Here, these letters and things of that nature are going to change just based off of what's actually going on at the airport. In this example, TS means thunderstorms and RA means rain. So here we have thunderstorms and rain. BR means fog, or it could be just some type of mist. Usually when you have any kind of precipitation, the automated weather observation system will always put in some kind of mist just because of how the components essentially work. It will also produce some kind of mist as well, even though in reality it's just really heavy rain. But it could also be causing some fog, which if you have heavy rain and you have some, pretty humid conditions, you can, essentially get some fog as well. The plus means that it's the intensity of the precipitation. So if there was no plus or minus sign here, that would indicate that you have just moderate rainfall or just plain old rain. But the plus here would indicate just heavy thunderstorms and rain. So here you would have perhaps maybe just some very, very heavy downpours in this example. If it was light rain, then it would just be minus RA or minus TSRA, meaning maybe there's a thunderstorm out in the distance and we're just kind of getting some residual rain or something of that nature. Now the next line here, line number 8, this would be the cloud cover. So here it denotes broken at 008. So the numbers that follow this would indicate what the cloud height is. So it goes tens of thousands to thousands to hundreds. So in this case, 008 means to say that it is a broken cloud deck at 800 feet. And a broken cloud deck essentially is just about 70% or so of the sky is covered with clouds. So here, 008 means to say that this is actually a ceiling height because broken or overcast clouds will denote a ceiling. Scattered or few clouds do not indicate any kind of ceiling. So here, this is a ceiling at 800 feet. So this would indicate IFR conditions at this airport. OVC, this would be overcast, and we have overcast skies at 1,200 feet. CB means is that the type of cloud would be cumulonimbus clouds, which makes sense because that's the type of clouds that produce thunderstorms. So in sky conditions, you can have different levels of clouds and you can have different ranges of cloudiness. So here you have broken clouds at 800 feet and you also have overcast clouds at 1,200 feet. And the type of cloud is a cumulonimbus cloud, hence the CB, which makes sense because there's a thunderstorm over the airport. Line 9, this would be the temperature and dew point. So temperature is first, followed by dew point, and this is always in degrees Celsius. The 10th line, this A here, this would be the altimeter setting. So pilots know how to set their altimeter in their cockpits. Here, this is the sea level pressure, but it is in inches of mercury. So this would be 29.7 inches. And then following that, the RMK is the remarks section. Now this will also vary and it will usually be put in by an observer if there is one, or it will just be automated by the TAF. Usually if there is a lot that follows this remark line, this RMK, then it's a good indication that it was an observer who basically put that in. So in this case, this press FR, this just means that the pressure is falling rapidly. That's essentially what this means. And so if you kind of look at some of the other weather phenomenon codes, if you will, we kind of talked about this. So if the intensity of the precipitation is light, then there's a minus sign in front of it. If it's moderate or heavy, there's a plus. But if it's just plain old rain, then there's really nothing. VC means in the vicinity. So a lot of times you see VCTS, meaning to say that there is thunderstorms in the vicinity. Maybe you're in a mountainous area and there's some thunderstorms, maybe like about 10 statute miles away, but it's not necessarily over the airport, but they're just really in the vicinity. And you also have some other weather codes as well. I'm not going to go through every single one of them. You can pause the video if you really want to see, but this is essentially how we denote what weather is occurring at what airport. So to take you through some examples here, these are all METARs, and essentially these are all relatively simple ones, but just to kind of go through what they are. So here, this METAR is for KORD. This would be O'Hare Airport in Chicago. This was automated on the 25th of whatever month at 12 Zulu. The wind was basically a northerly wind at 350 degrees, and it was rather light. It was about 5 knots. Now, there was a little bit of some restricted visibility, 5 statute miles. And what was the reason for that? Well, we had some light rain and fog in the area. And with that, we had a broken sky at 1,500 feet. So this would be MVFR conditions. And we also had overcast skies at 2,500 feet. So again, we have different levels of cloudiness, but both of these together would indicate some MVFR conditions. Now the temperature and the dew point, the temperature is 7 degrees Celsius and the dew point is 5. And it makes sense that both of these numbers are relatively near each other. Like the dew point depression is only 2 degrees here because, again, it's raining. So it makes sense that the relative humidity is high. The altimeter setting is 29.92 inches of mercury. And the remark here, you will most likely see a remark as AO2. AO2 basically means that it's an automatic observation with a precipitation discriminator, which basically just says that the ASOS at this location is equipped with a sensor that's capable of distinguishing between different precipitation types. So if it's sleeting outside, it will, wherever this is, and again, this is in this example, ORD, so O'Hare Airport, this automated weather observation system will pick up on if it's snowing or if it's raining or if it's a mix of sleet and freezing rain, whatever the case may be. And at the end of this remark, this would be the sea level pressure, and this would be in millibars. So here, this is, again, 13.4. How you read this is you basically put a period right before the last letter, right? And 13.4, this would basically be 1,003.4 millibars in this example. I'm sorry, this would be 1013. I apologize. So this would be 1013.4 millibars. That would essentially be what the pressure is. But again, it's not written in that aspect. And I know that might confuse some of you. So here's an easy way to think about that, right? So here's sea level pressure 13.4, okay? There's always a period before the last number. And so in this space here, let me kind of just move that out. In this space here, this number is either going to be a 9 or it's going to be a 10. If it was a 9, this would be 913 millibars. And given the weather conditions, that doesn't make any sense, because if this really was 913 millibars at sea level pressure, you'd have essentially a hurricane going on, and you would have much faster wind speeds, much heavier rain, and things of that nature. But here you can see that the winds are rather light and the rain is light as well. So 913 millibars doesn't make any sense here. This is why it has to be 1013.4 millibars. So that would be the sea level pressure in millibars. And here would be the sea level pressure, or the altimeter setting, in inches of mercury. Okay. So the next one here, this would be Los Angeles. Again, this was on the 22nd at 1530 Zulu. The wind was coming from 270. That's a westerly wind at 10 knots. 10 SM here, that means that visibility is 10 statute miles or greater. We don't indicate anything other than just 10 SM. So if there's no visibility restrictions, that's why you don't see any kind of weather here. They don't put anything if it's a clear day or anything like that. So here is a day where you don't have a ceiling, because you have few clouds at 2,000 feet and you also have scattered clouds at 10,000 feet. And so here, if you have few or scattered, right, this isn't broken or overcast. That means that there's no ceiling. So this is VFR conditions. So this is about as good as you can get. The air temperature is 18 degrees Celsius. The dew point is 10 degrees Celsius. Here's your altimeter setting. And then here's your remark. It's an automated system. And sea level pressure is 1020 millibars. Okay. So that's essentially how you go through all of the different METAR codes. So kind of just bringing that forward to how do you read a TAF. So a TAF basically looks like this. It kind of looks like a METAR, but there's a few extra lines and there's a few extra letters in there that mean different things. So how do you read a TAF? Well, a TAF is essentially broken up into 5 sections, more or less. The first would be the location that this TAF is meant for. Remember that a TAF stands for Terminal Aerodrome Forecast. So this would be a forecast at a specific airport. Now, not every single airport has a TAF associated with it. So if you're landing at a smaller airport, like a regional airport, most regional airports in the United States, they do not have TAF service for them, unless it's a private company doing it for a private client. So if you're landing at a certain airport and there's no TAF around, you could use the METAR just to kind of see what the weather conditions are going to be. Or what you could do is you could use a TAF from a nearby airport that does have one. So in this example, here's an airport KPDX. Now the second line here, this would be the time and the date that the TAF was issued. So in this case, it was issued on the 20th of whatever month this is, and the time is 1741 Zulu. So this would be the 18Z TAF issuance. In the United States, especially for the major airports, TAFs are usually every 4 hours, or I'm sorry, every 6 hours. They usually come out at 12Z, 18Z. There's also a 15Z, and there's also 21Z and 0Z. So basically every 3 hours, a TAF comes out. In that 3-hour mark, there are amendments to the TAFs, but every 6 hours would be a brand new forecast. An amendment just means that you're kind of tweaking a few things if you need to. Now, the third line means the time and the date in which the TAF is essentially valid for. So this forecast is basically good from the 20th at 18 Zulu, which makes sense because it was issued on the 20th at 1741 Zulu. So this is going to take us from 18Z on the 20th through 18Z on the 21st. So this is a 24-hour TAF. Now, the fourth, this is basically what the weather conditions are currently at the airport and what is expected to continue unless you have these from groups, which I'll describe what these are in just a minute. But here, if there's really no weather going on, don't be surprised that you basically just see a one-line TAF with no from groups from this. Because, well, there's really only one way to say that it's sunny and the wind is calm and there's no weather going on, if that's exactly what the case is. So in this case, VRB means to say that the wind is variable. It's not really coming from any sort of direction. And that usually happens when the wind is very light, usually generally under 5 knots or so. So it's variable at 3 knots. The visibility is past 6 statute miles. So this is P6SM, past 6 statute miles. So if the visibility is going to be 8 statute miles, 9, 10, whatever the case may be, it's not really going to be reflected in the TAF. It's just going to show up as P6SM. If there was a visibility restriction, then it wouldn't be a P here. It would just be whatever the visibility is. So if it was just 6 statute miles, then there wouldn't be a P here, and you would have some kind of weather section thereafter denoting why the visibility is essentially a little bit lower. And then here you can see we have scattered clouds at 4,500 feet, and we also have broken clouds at 6,000 feet. So this would be your ceiling, again, because we have broken clouds. So this would be 6,000 feet. Now, the from groups, this is essentially denoting what the changes in the weather conditions are going to be. So FM means from, so the forecast is going to essentially change from this top line on the 20th at 19 Zulu. So at 19 Zulu, the wind, right, is going to become more southeasterly or east-southeasterly here at 130 knots, at 130 degrees with winds of 8 knots. There's going to be no gusts here, so you don't see G or anything like that, like you would in a METAR if there were gusts. The visibility will still be P6SM, and we are going to see broken clouds at 20,000 feet. So those conditions are going to continue until we go to the next from line, which would be, now here the forecast is from the 21st at 2 Zulu. Now the wind is going to change another 30 degrees. It's going to become a little bit more easterly. So now here is 100 degrees. That's the direction where the wind is coming from, and it's blowing at 11 knots. Still visibility P6SM, but we do have some light rain in the forecast, and we're going to see overcast skies of 4,000 feet. Okay, so this is basically still telling you that, we do have some light rain, an easterly wind at 11 knots, and we really don't have any kind of visibility or ceiling restrictions. So we're still VFR according to this TAF. Then the forecast changes a little bit once again. So from the 21st at 13 Zulu, the wind changes and it becomes a little bit more southeasterly once again, 120 degrees, blowing at 14 knots, still P6SM and still experiencing some light rain. But you notice that the cloud height has reduced a little bit, and now we're at an overcast sky at 2,500 feet. That would be MVFR conditions. And this WS line thereafter, this is wind shear. So here we have wind shear in the lowest 2,000 feet of the atmosphere that wind shear is essentially coming from 190 degrees and it's blowing at 30 knots. So this is just some kind of indication that you have a low level jet in place and you have a difference in wind speed and direction from what you essentially have at the surface. So at the surface here, the wind is coming from 120 degrees at 14 knots. But essentially at a height of 2,000 feet above the surface, you have winds that are blowing at 190 degrees. So that's a little bit more south, or southerly, I should say. It's basically southerly. 190 degrees is southerly. And then it's blowing at 30 knots. So you have directional and speed shear. So if an if an airplane is trying to land on a runway, then they're going to encompass some type of wind shear. So the wind is basically going to be blowing at a faster wind speed and at a different direction than what it is at the surface. So this is going to alter how the pilot essentially lands the plane, and also how airport operation managers are essentially going to space the aircraft out. Because you have some hazardous flying conditions, you might want to space out that aircraft a little bit more, just so it kind of leaves some room so that, we don't have a bunch of airplanes all trying to land at the same time, and we can make things a little bit safer. So that's essentially the 5 parts to a TAF, but I want to show you just another example here. So this example is kind of the best of both worlds. This is a TAF and a METAR. So the METAR here, this was for KSLE. This is Seattle, I believe, or not Seattle. I don't actually know which one this is for. But this is on the 17th at 20 Zulu. The wind is coming from 180 degrees, 16 gusting to 21 knots. We have restricted visibility at 2 statute miles. The reason for that is that there's light rain and fog. We have low clouds, broken cloud deck at 1,000 feet, and overcast clouds at about 2,000 feet. The temperature is 11 degrees Celsius. The dew point is 9 degrees Celsius. The altimeter setting is 29.76 inches. And the remark here is that we have sea level pressure of about 1,007.9. And the P here, this is basically how much precipitation has fallen in the last 6 hours. So here P0, or the last hour I should say, P0004 would be 4/100ths of an inch of precipitation, and the T would basically be the pressure tendency change since that hour. Now here would be the TAF. Here you can see that the TAF was issued on the 17th at 1739 Zulu. It goes from the 18th, or I should say it goes from the 17th at 18 Zulu through the 18th at 18 Zulu. So this is a 24-hour TAF period. Currently, the wind is at 180 degrees, or coming out of the south at 17 knots, gusting to 24 knots. We have not past 6 mile visibility, but just 6 mile visibility, and that's due to some light rain and some fog with some low clouds at 1,500 feet. Now, this forecast basically stays true until 22 Zulu on the 17th. You notice that the winds do change a little bit. So we have 180 degrees. They're still southerly. The winds are at 12 knots, gusting to 19 knots. So the wind basically stays the same. But what changes is that you have changes in visibility. So here we have 2 statute miles with some light rain that's causing that. And we also have broken at 1,500 as well. If it was 2 statute miles and some light rain, me personally, I probably would have put some fog in there, just because light rain usually doesn't drop it to 2 statute miles. Or what I would have done is I would have just looked to see, is this really light rain, or maybe this is more heavy rain? Again, 2 statute miles with just some light rain seems a little suspect to me. Then that forecast basically stays true, or conditions basically stay true until you get to the next line. And then those conditions stay true until you get to the next line, and so on and so forth. So in this TAF here, you can basically see how conditions were okay. We had some light rain and some fog, and then conditions started to deteriorate a little bit, going from about 22 Zulu on the 17th through about 0 Zulu on the 18th. So basically just that 2-hour period, you can see that we had some visibility restrictions, and then you can see here the visibility started to get a little bit better. So for planning operations, the TAF is very useful because you can see what your biggest impact windows are essentially going to be. Then that forecast basically stays true until we get to 4 Zulu. You can see here that the wind gusts do pick up a little bit. The visibility does go down a little bit, and you can see that the rain goes from minus to there's no sign at all. So now we're getting into more moderate rain, and here you can see we also have some fog We have low clouds at about 2,000 feet, and then we also have some wind shear as well. And then that wind shear essentially goes away by the next time here. So FM, this would be the forecast is valid from the 18th at 11 Zulu. You can see here that the wind shear essentially goes away. So that's essentially how you read a TAF. Now, sometimes in a TAF, you won't see from groups, but you'll see tempo lines. And a tempo line just indicates that there's a temporary change in the forecast, which just lasts about 1 to 2 hours. Tempo groups can't exceed a 4-hour period by National Weather Service rules. So a tempo line can be used just to kind of keep your from groups a little bit less. So here you can see in this TAF, there's a lot going on, right? We have basically 1, 2, 3, 4, 5, 6 lines in a TAF, and that can be quite heavy. That can be a lot. But if you do some tempo lines here, it basically cuts out the need to put another from group in here, especially if it's going to be a short change. So here in this instance, right, here's the main forecast, right? You have your date, time, TAF validation period. So this is 260 winds. So this is more of a westerly wind at 10 knots. Visibility is a little restricted, 4 statute miles. We have some light snow and fog. And then we have scattered clouds at about 1,000 feet and overcast clouds at 2,000 feet. Now, this forecast is essentially going to stay the same until we get to 18 Zulu, because now we're indicating a tempo group. This is going to be a temporary change from this top line. So here's the tempo group. This tempo group means to say that the forecast is going to change just a little bit from the 20th of whatever month this is at 18Z through 20 Zulu. We're going to have a little bit of a change here. And that changes is that we're going to see reduced visibilities of 2 statute miles, still with some light snow and fog, and overcast clouds at 1,000 feet. After 20 Zulu, you will basically see the same weather conditions that are described in the top line. So when you see a tempo group here, once this tempo line expires, which would be at 20 Zulu on the 20th, the forecast will then switch back to the top line. And then you notice that from the 20th at 22 Zulu, the conditions change again. The winds basically change, become a little bit more northwesterly. The visibility improves a little bit. We still have some light snow and fog, and then here's your clouds. And then from the 21st at 6 Zulu, you can see how the weather changes again, and basically, whatever is causing this light snowfall and fog basically exits that airport, and now we're left with past 6-mile visibility. So now we have good visibility and scattered clouds at 4,000 feet. So again, scattered is not broken or overcast. So therefore, we're back to VFR conditions. So when a meteorologist writes a TAF, they basically have to take into a compass, what are the main information items that an airport manager or a pilot really needs to know in order to maintain overall safety and continuity and make sure things flow really, really nicely. So a meteorologist, when they're writing this, they kind of have to figure out, what is the needs of the airport, because wind plays a huge role in aviation. It's how airport operation managers essentially figure out what runways they're going to run the traffic on, because planes like to take off in the wind. It helps them get off the ground. They also like to land in the wind as well, because it also helps them to slow down. So those are just some examples of TAFs and METARs. And again, ending it with a tempo line, you could, in this instance, just put another from group, but then it would, kind of just look a little bit more messy, because you would need another line here to kind of denote what the change is going to be after 20 Zulu. So using a tempo line here kind of just makes everything a little bit neater in your TAF.